Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
We have covered all global timers. We have covered all timers of OSPF actually, all features of OSPF, and now even you can also control the CPU utilization in OSPF as well. Apart from that, you are also having some other options available in OSPF, but in iOS 15 only. And now I'm gonna to show you all those features of OSPF. Fine. Let me resume it. You are already done with it. See, you just need to configure keychain. Under keychain, you have to define your key number, and then you have to define a key string. After defining key string, you have to define a cryptographic algorithm, and you have multiple cryptographic algorithm available. Make sure that on both sides, on both ends, cryptographic algorithm must be same. This cryptographic algorithm will be defined under keychain itself, so that here you can configure multiple keys inside a single keychain, and then finally you will call it inside, see, under interface mode. To call it is very simple: IP OSPF authentication keychain and then your keychain name. That's it. That's what you need to do in cryptographic authentication. I hope you people have understood it. Next is graceful restart. First of all, you have to understand the feature, the uses of this feature actually. Graceful restart. I hope you people can read it easily. Is it readable from you guys? Fine. Try to read it now. The graceful restart feature in OSPF version 3. See, this is the feature of OSPF version 3 only. This is not the feature of OSPF version 2. So if you are running OSPF version 2, then you cannot configure graceful restart. So it allows non-stop data forwarding along routes that are already known, while the OSPF version 3 routing protocol information is being restored. This is called graceful restart. A device can participate in graceful restart either in restart mode or in helper mode. To perform the graceful restart function, a device must be in high availability stateful switchover mode. Do you remember in the beginning of the classes I discussed all these things, that in case if your one supervisor engine goes down of a switch, another supervisor will come up, but in that case your redundancy mode must be configured as SSO. So a device capable of graceful restart will perform the graceful restart function when the following failure occurs. A RP failure that result in switchover to standby. RP means that active RP will go down and standby will become active. A planned RP switchover to standby RP. Like for an example, you just wanted to test your standby RP, so you just perform failover manually. It was pre-planned. Now, the graceful restart feature requires that neighboring device be graceful restart aware. Fine. For further information about SSO and NSF, you can see all these documents as well. But to enable graceful restart, see, graceful restart will be required in that case only when you are having two 6500 series of switches or 4500 series of switches, and both of them are having redundant supervisor engine as well, and their redundancy mode is configured as SSO. So you know very well that in case of SSO, their failover timer is less than 1 second. So within that they have to reestablish their OSPF neighborship as well. So in that case, this graceful restart is really important. See, OSPF version 3, and this is process 1, and then you have to configure this command only, graceful restart. That's it. To enable it, Graceful restart.
So to save that 1 second, then you can easily use function.
What?
To save that 1 second.
No, not to save 1 second. See, in case if your OSP neighborship goes down, then it will flush all routes available from its routing table. And again, there will not be any advantage of having your failover time less than 1 second. Because if neighborship goes down, then definitely your traffic will not be forwarding, right?
But redundancy is there.
That's what redundancy? Where is the redundancy of routing table? There will be only one routing table available, right? So in this way you can configure graceful restart. So I hope that you people have understood it. See, once again, it's definition. The graceful restart feature in OSPF version 3 allows non-stop data forwarding along routes that are already known while the OSPF version 3 routing protocol information being restored. So there will not be any effect on your data forwarding. For that purpose, it is really important to enable graceful restart in OSPF. Like in EIGRP, graceful restart is already there. Like when you configure distribute list, it performs graceful restart. I mean resync. Graceful resync. It does not mean that for that moment it will stop to forward your data. No, it will keep on to send your traffic during that period. I mean, meanwhile it will also refresh itself. Now,
Go into the router mode and
exactly, just graceful restart. Only one command is there.
after this command, immediately you go into like you do a graceful restart, or the next time the RP fails.
Of course, after that only. Because the uses of graceful restart will come whenever any RP will go down, and standby will come up. If it doesn't go down, then there will not be any requirement of having graceful restart in OSPF. So I hope that you people have understood the uses of graceful restart in. So yes, graceful restart. Now there is one another option as well, graceful shutdown support for OSPF version 3 as well. Graceful shutdown. This is not restart. You know, in BGP it is by default there. When you say neighbor shutdown, on another end neighborship goes down immediately. But in OSPF we do not have that feature. I mean, we were not having that feature available till now. But now we are having that feature. Like for an example, the graceful shutdown for OSPF version 3 feature provides the ability to temporarily shut down the OSPF version 3 protocol in the least disruptive manner and to notify its neighbor that it is going away. Otherwise, what will happen? Let's say for an example, you have removed your OSPF process. The neighboring router will break neighborship after the expiration of that interval only. Hello. Neighbor device will break neighborship after expiration of that interval only. But with using this feature of graceful shutdown, just use your graceful shutdown feature of OSPF version 3. Just shut down your process at your own end, but you will see that at the end of neighbor, the device will go in shutdown mode automatically. Hey, it will immediately come to know that neighbor have gone away. The neighbor have broken neighborship. Have you people understood or not? Otherwise, your neighbor will break neighborship after expiration of that interval only. To enable this feature, it's very simple. I mean, it is by default enabled actually. You are not required to enable this feature. You have to simply say shut down inside the router mode. You will see that at the end of neighborship will go down immediately. Neighbor will not wait for the expiration of that interval. It will immediately notify its neighbor. Simple. Right? So this is called graceful shutdown in OSPF. Prefix suppression. Sometimes what happens that I want to keep my neighborship, but I don't want to advertise my own prefixes to any neighbor. I don't want to advertise my own prefixes information to my neighbor. In that case, you can use this feature of OSPF, which is known as prefix suppression. See, the OSPF version 3 prefix suppression support feature allows you to hide IPv4 and IPv6 prefixes that are configured on interface running. See, OSPF is running onto interface, but you want to hide them. You don't want to advertise them, right? You want to hide them. In that case, you can use prefix suppression. In OSPF version 3, addressing semantics have been removed from the OSPF protocol packets and the main LSA types, leaving a network protocol independent core. This means that router LSA and network LSA no longer contain network addresses but simply express topology information. So your neighbor will come to know about topology information, but you are not going to express your network information, your prefix information. The process of hiding prefixes is simpler in OSPF version 3, and suppressed prefixes are simply removed from the intra-area prefix LSA. Prefixes are also propagated in OSPF version 3 via link LSAs. The OSPF version 3 prefix suppression feature provides a number of benefits. The exclusion of certain prefixes from advertisement means that is more memory available for LSA storage, bandwidth and buffers for LSA flooding, the CPU cycle for origination and flooding of LSAs and SPF computation. Prefixes are also filtered from link LSAs. A device only filter locally configured prefixes. See, with using prefix suppression, you can suppress only those prefixes with using prefix suppression feature in OSPF which are directly connected to you. You cannot suppress those prefixes which are received from any other neighbor and you are advertising them towards another neighbor. Like if you have received any prefix from one neighbor and you are advertising them towards another neighbor, you cannot you cannot suppress them. You can suppress only and only directly configured IP addresses, directly configured networks only. And the command will be simple prefix suppression under router mode. But remember that all these features like graceful restart, graceful shutdown, prefix suppression can be configured in OSPF version 3 only. Even in OSPF version 3, they have also added one new feature, is creation of address families for IPv6 as well. Like till now, it was mandatory to run different processes of OSPF for IPv4 as well as IPv6. But in OSPF version 3, we can configure both of them, IPv4 as well as IPv6, within a same process by using address families same as BGP. Right? So these options are available here. So the command is very simple to configure prefix suppression, is simple prefix suppression. Prevents OSPF from advertising all IPv4 and IPv6 prefixes except prefixes that are associated with loopback secondary IP address and passive. It's really required. It's really useful feature of OSPF. Let me tell you why. In BGP, only those prefixes will be advertised which you are advertising them manually. And generally in BGP, you have seen that we advertise only lane prefixes, right? So in OSPF R1, like here you can see in this diagram, is it really required to advertise these prefixes which are running in between R1 and R9, which are running in between R11 and R9? Of course, only their lane network should get advertised. Only lane information should be advertised into OSPF. I hope you people are getting my point. See, only lane information. Why WAN information? It is simply consuming more and more memory, CPU cycle. Are you getting my point or not? So for that purpose, you can use prefix suppressor so that it will not advertise transit networks. But remember, passive interface should be configured over there. On-lane interface so that it can advertise them into LSS even after configuring prefix suppressor. And by default, loopbacks will not be suppressed. So I hope that you people have understood the uses of prefix suppression in OSPF version 3. So all these things are really new in OSPF version 3, and I hope that now you have learned all these things available in OSPF. Yeah, this is virtual link and TTL security hops is what?
Yeah.
Simple. Have you understood it now? So in this way, you can also use TTL security for virtual links as well. And I have told you that why is it necessary. Like for an example, if your virtual link neighbor is just 3 hop away, then configure here TTL security hops is what? 3. It means you are specifying it. Okay, your virtual link neighbor is just 3 hop away from here. So if anyone have spoofed your IP address and then trying to attack on you on your device, it will not be possible for that, because we can identify attackers by checking their TTL values. So I hope that you people have understood it now completely fine. So this is all about OSPF version 3, and now let me open that PDF file of Cisco CCRNS version 5 lab. Let's see all topics available for OSPF. Still we have not gone through, as you all remember, these address families. So it's very simple. I will let you know later on during IPv6 that okay, in it we can also configure address families. So forget about it. But apart from it, like network type done, LSA types done, internal router ABR ASPR done, virtual link done, general operations like I have also gone through these general operations: graceful shutdown, TTL security mechanism, you understand?
Yeah.
Matrix, LSA throttling, SPF tuning, fast hello, LSA propagation. ISPF is still left, which is known as, I think, incremental SPF. Incremental SPF. Don't worry, I will discuss it, right? But for now, see, prefix suppression is also done, right? LFA is still left. I mean, LFA is still not covered. Loop free alternative path. You can say fast reroute is still left in OSPF. And do you remember the uses of fast reroute in EIGRP? Do you remember that? In EIGRP you were already having feasible successor, but there in OSPF there is nothing like feasible successor. Only and only best route information will be stored inside routing table. There is no concept of feasible successor. So in OSPF might be that you are having a backup path, but still if your primary goes down, then it has to run SPF algorithm, and then after it will come to know that okay, it can also reach these prefixes via this another path. So it will take so long time. So in OSPF also you can enable fast reroute, and to enable fast reroute it is very simple. There must be fast reroute here.
वही जाके में पासिंग राउट से जो हम CF में लिखते थे वो रिटायर पाथ
yes,
सेट कर दे रहा हूँ, तो उसमें भी वैसे ऐड कर देगा।
exactly same, it's the same feature, same which we were having during ESCRP. Even command is also same, so it will be better for you to do it by yourself. Guys, you can do it by yourself. I'm 100% sure about it, because the command is also same as ESCRP, like fast reroute and all these things. Incremental SPF. See, OSPF uses Discustra SPF algorithm to compute the shortest path tree. During the computation of SPT, the shortest path to reach nodes is discovered. The topology tree is used to populate the routing table with routes to IP networks. When changes to type 1 or type 2 LSA occurs in an area, the entire SPT is recomputed, right? In many cases, the entire SPT need not be recomputed because most of the tree remains unchanged. Incremental SPF, just try to understand it, allows the system to recompute only the affected part of the tree. So I hope that you have understood the meaning by incremental SPF. See, there is a rule that whenever there will be any change in type 1 or type 2 LSA, then you have to recompute SPF algorithm, right? During that SPF algorithm execution, of course, the CPU cycle will be higher. To reduce that, you can enable incremental SPF, because generally what happens that it is not always mandatory that your entire SPT will get changed. No, might be possible that a specific part of the SPT got changed. So for that purpose, here you are having ISPF. So you see, in many cases, the entire SPT need not be recomputed, is not it? Because most of the tree remains unchanged. The incremental SPF allows the system to recompute only the affected part of the tree. Recomputing only portion of the tree rather than the entire tree results in faster OSPF, right? Convergence and save CPU resources. Note that if the change to type 1 or type 2 LSA occurs in the calculating router itself, then full SPT is performed. Right? Incremental SPF is scheduled in the same way as the full SPF. Routers enabled with incremental SPF and routers not enabled with incremental SPF can function in the same internetwork. It's not like that to form neighborship on both routers ISPF should be enabled. But I hope that you have understood the uses of ISPF now. See, it is not always necessary that after receiving any change it should run. It should recompute entire SPT. So test path tree. Might be that there was a change, but it was a small change. It was in a specific portion of the SPT, right? I mean, change was belonging to a specific portion of SPT. So it will be better for you to recompute that part of SPT only, not the entire SPT. You understand what I mean to say? So for that purpose, here you are having incremental SPF. So you can enable it by using this command only. Under OSPF, under router mode, you just need to enable ISPF, and it's very simple. Even you can also enable it here as well. Router OSPF 1 ISPF. Show IP SPF. Now it will show you that incremental SPF is enabled. So in this way you can enable incremental just to save your CPU resources. Hello, have you understood it or not? So all these features are available in OSPF, and now I have not left anything. See, we have covered all options, all topics of OSPF version 2 as well as version 3 theoretically. Yeah, we have not performed the practical of OSPF version 3 yet. I'll do it during IPv6 only, right? I'll perform all these practical during IPv6 only. Before that, I'm not going to perform all these things. What? Yeah, it is same as like fast reroute. The fast reroute is configured with single hop, whereas LFA is also same as fast reroute, but it will be configured with using multi-hop. That's the only difference in between fast reroute and LFA. What? LSA 9. It is, they have created this type 9 LSA in OSP version 3 only, which is known as linked LSA. Just like router LSA, right? Just like router LSA. So link LSA is there just to perform prefix suppression. Just to perform prefix suppressor. I mean, with using link LSA, I mean, inside link LSA, this facility is available to perform prefix suppression and all these things. That's why over there they specified that prefix suppression can be done in link LSA. So now only BCP is left.
So if we get capability transit.
Yes, there is. See, sometimes what happens that, let's say that we have configured a virtual link R1, R2, R3, R4, right? And let's say this is R5 as well. Here area 0 is running, area 1, area 2, and also here area 2 is running, here area 0 is running. Now you see that for area 2 you configured here virtual link for redundancy purpose over area 1, but it will never become the best path for area 2, never ever. For that purpose now you will require to disable that transit capability. But again, if this link goes down, what will happen? See, this R5 has gone down. What will you do now? So in that case, you will require to disable that capability feature.
रूटिंग प्रेफरेबिलिटी चेंज जाती है, मतलब कुछ कौन सा रूट प्रेफर करना है?
Via, without virtual link, of course, it will prefer that path only. If it is going through virtual link, it will never prefer it. So to solve, to solve that problem actually, because it does not consider its best path via virtual link, right? If it is having another path without virtual link. So to solve that problem, here you will require to disable that transit capability and all these features. And I hope that the command is, I don't exactly remember, but the command will be something like this: router OSPF1 area 1 capability transit. Yes, no capability transit. You have to configure this command. Command is something like this. I'm not 100% sure, but command is something like this. And I hope that you have also understood the uses of this command as well. That's the only uses of this thing. So I hope that you people have understood all these things now, the concept behind OSPF.
So guys, this was the last video of OSPF. I hope you learn a lot from this topic. So we'll be coming with few more videos. So please subscribe my channel. That's ARC_tutorial, and we'll be coming back with few more videos. Thank you guys. See you later.